Combustion and flame. Let us learn about this chapter. In this chapter, we will learn what is combustion, what is flame, what are fuels. Combustion is defined as burning of any substance. Another definition for combustion. It is defined as chemical change. Chemical change. In previous classes, you have learned about two kinds of changes, physical changes and chemical changes. Do you remember? Chemical changes are non-reversible. They are permanent changes. And in chemical changes, new substances are formed. During a physical change, there are reversible changes, and the changes are temporary in nature. No new substances are formed. So, combustion is particularly having a chemical change. Combustion is a chemical change taking place in presence of oxygen, in which both heat and light is produced at the same time, and composition of substance is also changed. That means a new substance is formed. We have burning of coal as the example of combustion. It is a chemical change. Similarly, ice is the solid state and it gets converted to liquid, and vice versa. So these are physical changes only. There is no new substance formed, only H2O. Water is the chemical composition. Is it okay? So, conversion of various states of matter in the case of water is a physical change. Perfect. So, combustion must be a chemical change. Only then we can say it is combustion. It is always done in the presence of oxygen. Oxygen is taken from air, surroundings, the atmosphere. Both heat and light are produced, and the composition of substance is also changed. That means something new is formed. Like we burn a piece of paper and it gets converted to ash. So it is a chemical change. This change can't be reversed. So, we can say that the combustion process takes place in presence of supporter of combustion, that is oxygen. Oxygen is the necessary condition for combustion. Is it clear to all of you, dear students? The process of burning of coal is always done in the presence of oxygen, and heat and light are released. So, the composition is completely changed. Burning of coal, burning of paper, burning of candle are some other examples of chemical changes. In all these three cases, the necessary conditions for combustion must be there. Dear students, answer a simple question. Here there is a picture showing burning of coal and lighting of an electric bulb. Tell me, which out of both do you think is showing you the presence of the process of combustion? When coal is burnt, heat and light are produced. And when we switch on a bulb, an electric bulb, it starts producing heat and light. So, according to you, which is the process of combustion and which one is not? Give your reasons in the comment section. I'll be waiting for your answers. Very good. Some of the students have started answering the question. Actually, lighting a bulb or switching on an electric bulb is not a process of combustion, because here no new substance is getting formed. In combustion, chemical change must occur. So, what are the conditions required for combustion? The conditions required are the presence of a combustible substance, supporter of combustion, that is oxygen gas O2, and attainment of ignition temperature. On the basis of combustibility property of any substance, they are of two types: combustible substance and non-combustible substance. Combustible substances undergo the process of combustion easily, and non-combustible substances do not undergo the process of combustion at all. Can you give some examples of combustible substance? Very good. Combustible substances have examples like paper, wood, fossil fuels, LPG, etc. Substances which are combustible are able to catch fire easily, like we have kerosene and petrol. These undergo combustion, or you may say they burn with ease. Non-combustible substances. These are the substances that do not catch fire easily. For example, glass, stone, etc. Ignition temperature. It is also known as kindling temperature. Kindling, kindling temperature. Students, it is the lowest temperature at which a substance catches fire. It is necessary condition for combustion. Until and unless a substance is raised to the temperature of being ignited, it doesn't catch fire. Like kerosene. Kerosene is stored in bottles at our homes, but it doesn't catch fire at room temperature because its ignition temperature is higher than the room temperature. Ignition temperature is actually different for different substances. Some substances like sodium have the ignition temperature as low as the room temperature. So, sodium catches fire when it is kept in open, where all the three conditions for combustion are fulfilled. Let us enhance our knowledge now. Tell me, out of dry leaves and wet leaves, which catches fire easily? Dry leaves catches fire easily because it is not having moisture in it. On the other hand, wet leaves have water present in them, which increases its ignition temperature. Is it fine? Have you understood the concept? Next question. Why petrol catches fire easily than kerosene? The answer is because of the low ignition temperature, petrol catches fire easily as compared to kerosene. Combustion process depends on the ignition temperature. Kerosene and petrol both are combustible substances. Both catches fire, but when compared, then we find that petrol has ignition temperature lower than kerosene. This is the reason that petrol is easily burnt up. Okay, that's all for today. Thanks for watching.